This video is meant to show you how to create a Mousetrap car calculator. Some things we need to know before we get started are the parameters of the car. So we're going to create a few cells that are labeled with those parameters in them. So let's start with the mass of the car, mass of the wheels, and the mass of the axles. We also want to know what the spring constant is and the spring torque offset, because those describe the Mousetrap spring. We're also going to need to record the axle spring distance and the lever arm length. Axle radius and the wheel radius are both very important for determining the overall acceleration. And we'll include a deceleration constant for our measurement of the friction in the vehicle. And finally, the spring angle. Let's make everything fit into that first column, column A. As always, it's very important to keep track of our units. So let's type the units into column B. Notice that the spring constant is in Newton meters per radian and the spring torque offset is in Newton meters. Now let's create a space for some of our calculated values. We have the spring angle in radians. We have the lever angle in radians. The Mousetrap torque in Newton meters. The lever arm force. The axle torque. And the moment of inertia for both the wheels and axles. Okay, so now we have the car acceleration and all of our calculated values labeled. Let's go ahead and put in the units again in column B. And finally, meters per second squared for the car acceleration. Let's take a few example values from our worksheet. And now that we have values in place, we can start typing in the equations from our physics model. First, of course, we calculate the radians based on the degrees. We also calculate the lever angle based on the spring angle. For the Mousetrap torque, we need to use the linear equation with the spring constant as the slope and the spring torque offset as the y-intercept. Next, the lever arm force depends on the Mousetrap torque. And the lever arm length. So the actual torque depends on the lever arm force and the axle radius. Now the moment of inertia depends on the mass of the wheels, the mass of the axles, and the radius of the axle and the radius of the wheel. Notice that we're using a mass of 0 for the mass of the axles right now. Okay, let's work on the car acceleration now. Car acceleration depends on the wheel radius times the axle torque divided by the mass of the car. And the wheel radius squared minus the moment of inertia. Minus our deceleration constant, which is 0 for now, until we have measured the friction in our specific car. Okay, so let's review. We can look at all the formulas that we typed in using the control backtick, which is the key directly below the escape key. As we review, we can find our own mistakes. So for instance, here we see a mistake in the lever arm force and also in our moment of inertia calculation. Now let's do some formatting. We can format the input cells as input and the calculation cells as calculations. And these figures seem to be obscenely long and difficult to read. We can reduce the precision displayed so they're easier to read. They're closer, a little bit more realistic, since we all know that the precision of our outputs, our calculations, depends on the precision of our inputs as they were measured. So this is our first Mousetrap calculator. Thank you for your time.